this is not going to be 1 because this is not sine theta over theta. It's sine of something over something else that's similar, but not identical, right? If this was sine of 3x over 3x, then we go, oh, well, these are the same thing. And if x is going to 0, 3x is going to 0 as well. So one way to deal with this is the following. You can say, oh, I need to get a 3 on the bottom, so I'm going to multiply 3 on top and bottom, right? And then these two can be grouped together. I'll have 3x on bottom, and this 3 I can move out in front. So this equals 3 times the limit as x goes to 0 of sine of 3x over 3x, so that these two things are identical. They're one and the same. And then you could go, okay, well, if x is going to 0, then 3x is going to 0. So, this is going to be 3 times 1, right? This limit is equal to 1 because the two things are equal now. Well, it depends. You have to be careful with that. So with this one, yes. But if we want to be really careful, we can do this. We can do what's called a change of variable. And I can say, okay, I'm going to say that theta equals 3x because in the theorem we have sine theta over theta. Well, whatever it is that is inside the sine function, I'm going to call that theta. And then I can ask, okay, when x goes to 0, where does theta go? What is the limit as x goes to 0 of theta? Well, that's the limit as x goes to 0 of 3x. And since that's a polynomial, we just plug in 0 and we get 0. So I can do a change of variable. I can say, this x is great and all, but the theorem does not have a 3 in it. So although I'm confident this is going to work because the 3x is the same thing in both positions, this is not literally what the theorem says. But if I make this change of variable, then I can replace 3x with theta, right? So then I can say, well, this is going to be 3 times the limit as theta goes to 0, right? Now, when theta goes to 0, which is kind of what we're saying here, theta goes to 0, well, sorry, let me rephrase that, my mistake. I almost said it backwards. We already are having to deal with x goes to 0. That is where x is going. And when that happens, theta also goes to 0. That is what we confirmed. When x goes to 0, theta goes to 0. Okay? So I can switch over in the limit to that other variable. So this will be sine theta over theta. Okay? And now that's literally, this is what the theorem tells us about. Sine theta over theta. So I've switched the variable over. So now this is 3 times 1. Which would be 3. So if we're not worried about covering all our technicalities 100% of the time, then we don't need to do this in this example because I can say, oh, well, 3x and 3x, those are the same thing. And the theorem has sine of something over that thing. That's what I have. And then, 3x does go to 0 when x goes to 0. So we're sort of implying this change of variable when we say, oh, well, 3x does go to 0. We're implying this change of variable without explicitly writing it. However, there are times when we kind of need to write it explicitly so things are as clear as possible. So I can do a change of variable in this way. This is something that we're going to want to do in some of the examples that we do in chapter 4, section 6. So if I had something like this, if I had, and I wonder if somehow that can inform this. I suspect that it could because it's similar. Because you could say, oh, well, theta equals x squared. You could try something like that. That might be something you could do to deal with that one. Anyway, but what about this? What if I had, say, sine, let's say, oh, I'm sorry, limit, of course, limit, let's say as x goes to, x goes to 5, okay, of, let's say, sine of, let's say, x squared minus 25 over, let's say, x minus 5, right? So this is a fair bit more complicated than this one with the 3 in it. But it's a similar idea in that there's more stuff going on. And something I skipped here, I skipped plugging in 0 to see what would happen. Here, let's plug in 5 and see what we get. So I'll say, oh, this is equal, even though, generally it doesn't work out that way. That's why we're going through all these details, seeing what do you do when it doesn't work out. So if I plug in 5, I'll have sine 5 squared minus 25, right, over 5 minus 5. Of course, the bottom is 0, right? In the numerator, 5 squared is 25, and if you subtract 25, well, now we have 0, and sine of 0 is 0. Ah, indeterminate form. That means plugging in doesn't work, right? So we have to try something else. What do we try? Well, what some people will try to do, and while I think sometimes you end up getting the right number at the end, your answer is correct, the method is totally wrong. Remember that these parentheses do not imply multiplication. So we can't say, oh, we're going to cancel this x squared minus 25. So what some people will do is they'll say, oh, I'm going to factor, and I'm going to change this to red to emphasize that it's wrong. They're going to say, oh, I'm going to factor sine x minus 5 x plus 5 all over x minus 5, right? Change colors again, and then they'll say, oh, we're going to cancel that. That does not work because this sine of x squared minus 25, well, you could factor within the sine function. You could have sine of, in parentheses, x minus 5 times x plus 5 if you wanted, but they're still contained within the sine function. This x minus 5 on top is not available for cancellation because it's not multiplied against sine. It's inside the sine function. So although you can write this, you really need extra parentheses as the container for the sine function, for the input of the sine function. Okay, so trying to do cancellation simply does not work. It has no. It kind of looks like you might, right? But it simply is not relevant to this problem. There's no way to cancel any of this stuff inside the sine function. It's not available for cancellation. So what do you do? Well, and I think the homework problems on WebWork, none of them are quite this complicated, but it's a good example of how to handle change of variable, which again, we need in the next section anyway. So I can say, okay, the limit, I'll just copy it here, actually, first, and then say what I'm going to do. The limit as x goes to 5 of sine x minus, x squared minus 25 all over x minus 5. What I can do is I want this denominator to be identical with, I can multiply top and bottom by x plus 5, so that this x minus 5, when I FOIL it with the x plus 5 that I'm about to put over here, I'll get x squared minus 25 on bottom. Okay, so I'll have x plus here and x plus 5 here. These two I'm going to FOIL together, and I'll cut corners a little bit, and I'll skip that step. Hopefully everyone's okay with that. So this equals the limit as x goes to 5 of sine of x squared minus 25 over x squared minus 25 times x plus 5. Okay? So now what I can do is I can use the product rule. I say, well, this is equal to the limit as x goes to 5 of sine x squared minus 25 over x squared minus 25 times the limit as x goes to 5 of x plus 5. Okay. Now in this limit here, well, this one's easy. It's just the limit of a polynomial. You plug in 5, you get 10. That one's easy. Here, one way to do it, if you weren't super concerned about showing all the details, you could say, well, if I plug in 5, I'm going to have sine 0 over 0. I have x squared minus 25 on top and on bottom. It's identical. It looks like sine theta over theta. Oh, so I know what's going to happen. I have sine theta over theta. Theta goes to 0 when 5, x goes to 5. I know I have 1. Yeah, you could do that, but you're not showing what's happening. You're thinking a change of variable, but you need to write what you're doing. So I don't think I'll put one this complicated on an exam, so don't worry too much. None of the homework problems are this complicated, I don't think, so don't worry about that. I wouldn't put one that's more complicated than homework problem. Let's put it that way. And I don't think any of them are this complicated. So what I could do is say, okay, well, theta equals x squared minus 25, and the limit as x goes to 5 of x squared minus 25, which of course that's theta. Well, if that's a polynomial. Well, let me fix that. That's a limit of a polynomial, right? Quadratic. Well, I can say, oh, well, that equals 0. You plug in 5, you get 0. Let's put this in a little box over here. So I know that theta goes to 0 when x goes to 5. So I can switch this limit over to being a limit about theta. So this equals the limit as theta goes to 0, right? That's where theta is going. Theta goes to 0. We just showed that. Sine theta over theta times 10. That one was easy. So now I have 1 times 10, right? Which is, of course, 10.